Okay, so this is problem number 20. And just so you guys know, it's a blue problem, so blue problems are really tricky. The first part is pretty straightforward, but the second part is really tricky, and it's actually the only way that I can see to solve it is by using something that we haven't gone over in class yet. So this will be a first introduction, or you might have seen it in physics last year. Okay, so 20 has this graph with acceleration versus time, and it asks for what the velocity is at 10 seconds, and then it asks for what the velocity is at 20 seconds. So if I write my givens down, here they are, 10 seconds. I get this 2 meters a second squared from the graph. And it starts from rest, so the initial 0, and I'm trying to find out what my final velocity is. So if I use the equation that my acceleration is my change in velocity over time, and I rearrange that and solve for v final. Since this is 0, it just ends up giving me acceleration times time, or 10 times 2, which is 20 meters a second. Okay, so that's pretty straightforward. And then it also asks what is the velocity at 20 seconds. And so at 20 seconds, At 20 seconds now, I have an initial velocity of 20 meters a second, because that's what it ended off at 10. If you take a look at the graph, you can think of from 0 to 10 seconds. Right here, it's moving 20 meters a second, and this says it's not accelerating. Acceleration is 0, so it stays moving 20 meters a second. So in this case, my initial velocity is 20 meters a second. But my acceleration now from 15 to 20 is -3. And so that's over a 5-second interval. So I'm trying to find out what my v final is. So if I use this same formula up here, but now isolate v final, but I do have a v initial, then I get 20 plus -3 times 5, which is 5 meters a second. Okay, so A is pretty straightforward. B though, B asks for what is the total distance traveled. So if I look at the total distance, I have to add up. I have to say like, okay, what's the distance traveled on this time? What's the distance traveled on this time? And what's the distance traveled on this time? So then I'll have to add those all up. So the distance from 0 to 10, the distance from 10 to 15, and the distance 15 to 20. So for the first part, 0 to 10, if I write my givens down, I have an acceleration. My time, it's over 10 seconds. It starts from rest, or my initial velocity is 0, and my final velocity is 20 meters a second. And we found that in this problem right here. So here's the formula that we're going to learn. So this is a constant acceleration formula to solve for your displacement. And so this formula, I'm going to use it. The initial velocity, since that's 0, this whole thing will become 0. So I just have delta x is equal to 1/2 at squared. And then I plug in my values, and I end up with 100 meters for this first section right here. Okay, now if we go to this section right here, from 10 to 15 seconds. Well, this one's easy because there's no acceleration. So this is just a constant velocity. So we know that it's moving at 20 meters a second because at this point it was 20 meters a second and there's no acceleration. So it stays 20 meters a second. And time was for 5 seconds. So then I'm going to use the formula for constant velocity. Velocity is equal to displacement over time. And then I just solve for my displacement, and I get 20 times 5, which is 100. Alright, so for the third one, we could actually use a couple of equations, but I'm just going to stick with the one that we used here. My given now, so now my acceleration, instead of being 2 meters a second squared, it's -3, because that's what the acceleration is over that time period. So and my initial velocity now is 20 meters a second, because that's how fast it's moving when it hits the 15 second time period. My time is 5 seconds, and I'm looking for what my delta x is. So same formula as above, but this time I have an initial velocity, so I have to plug that in. So I get 20 times my time period, 5, plus 1/2 a t squared. This one doesn't work out evenly, it gets a decimal, but I end up with 62.5. And then if I add all this up, I get delta x is equal to 100 plus 100 plus 62.5, and that's equal to 262.5. Alright, hope this helps.